onwards we are going to start with a new topic, that is hydrostatic pressure on the curved surfaces. Let us understand the curved surfaces first and then we will go for some numericals. So today we will start with our topic, hydrostatic pressure on the curved surfaces. Now let us see here. So this is the free water surface and this is the curved surface A, P and C is the midpoint here. Now there are the two, the pressure is acting in the two components. One is horizontal component and another one is vertical component. This is horizontal component and this is vertical component. Okay, and the resultant is here P. Resultant is P. Let take any depth y from the free water surface. Let us see this is the y. Okay, this is y and y into dA, small elemental area on the curved surface. That is, so F is equal to here. F is equal to integral of W into y into dA. Okay, already we have written here. So okay, then there are the two components. One is horizontal component dph and dpv. So dph is the horizontal component and dpv is the vertical component. So let us resolve these two forces. Okay, so df, small elemental force df sine theta, that is P into dA sine theta. Already we have obtained this expression in earlier classes. So dF is equal to P into dA, force is equal to pressure intensity into area. So dF into sine theta, so P dA sine theta, dph, and dpv is equal to dF cos theta. So horizontal component is in sine theta, whereas the vertical component is in dF cos theta. So P dA cos theta. Okay, so these two components we got it. So dph is equal to P dA sine theta and dpv is equal to P dA cos theta. Okay, now when we want to note down the complete force, complete horizontal force, total horizontal force, so ph is equal to integral of dph, small elemental force, horizontal force, that is dph, that is equal to W integral of y dA sine theta. Okay, where W integral of y dA sine theta is a force on a projected area of the curved surface on a vertical plane. Okay, whereas PV is equal to integral of dPV is equal to W integral of y dA cos theta. Okay, so this is total horizontal force and this is total vertical force, where d integral of y dA cos theta is a force on the projected area of the curved surface on a horizontal plane. So let us say this is the horizontal plane. This is the horizontal plane. Okay, and whatever the force is acting on the horizontal plane is dPV. This is dPV. dPV is acting on the horizontal plane and dPH on the vertical plane. So when we take dPV is equal to W into integral of y dA cos theta. Y dA cos theta. So y dA, so this is area, total area, and y into dA or area and cos theta. Okay, so where W into integral of y dA cos theta is a force on the projected area of the curved surface on a horizontal plane. Okay, this is the horizontal plane and this is vertical plane. So when we take H, so this is the triangular force. This is equal to W into H. This magnitude is W into H, and this is total height of the water from the free water surface. This is H. This is H. Okay, and the pressure intensity is increasing gradually at the base and lowered at the top or the free at the free board. Okay, so let us say this will act at h by 3. this will act at h by 3 from the base. This will act at h by 3 from the base. This pH will act at h by 3 from the base. So here also we done same thing. Yeah, f is equal to w integral of w y dA. Okay, then pH is equal to df sin theta into p dA sin theta. Okay, and pv is equal to df cos theta is equal to p into dA cos theta. Okay, so pH is equal to integral of dpH is equal to w y dA sin theta, force on the projected area on the curved surface from vertical plane. When we see the let us say this is the vertical height of water surface, and when we see from this side, this appears to be a rectangular lamina. This appears to be rectangular one. So let us say this is height water surface, or height of the weir or anything, height of the dam, and this is the width of the dam. This is width of the dam. So W into H is the area, and this is y bar, and area is this. So pH is always equal to W into A into y bar. WA into y bar, and dPV is equal to W into y dA cos theta, that is force acting on the projected curved surface in the horizontal plane. So let us say this is the horizontal plane. So resultant pressure is equal to PR, or P is equal to under root PH square plus PV square. Already we have studied this thing in the applied mechanics in first year, and tan theta is equal to PV upon PH. So theta is equal to tan inverse of PV upon PH. Okay, so this is the theory behind the hydrostatic pressure on the curved surface. Now let us begin with the problem one by one. Let us move for problem number 1, asked in the gate examination, common data question. A cylindrical gate of 6 meter in diameter and 4 meter in long, has a water on its both sides as shown in the figure. So at this point it is 6 meter upstream side. Let us will mark it as upstream side. Upstream side it is 6 meter, and at the downstream side it is 3 meter. Okay, so what he wants to ask, that is, first of all we'll have to find out the magnitude of the resultant force, that is Fr. He want to find out Fr magnitude. Then direction of the resultant force, that is tan inverse theta, or theta is equal to tan inverse of PV upon PH. And lastly, that what should be the weight of the cylinder? So that it will not be lifted away. From the base of the floor. Okay, so this is not to be lifted. It is not to be lifted up. Now we'll solve the problem one by one. So first of all, we'll calculate pH1. That is horizontal pressure at upstream side. That is upstream side means this side. Okay, when you see from this side, this rectangle will appear like this portion will appear like a rectangle. Okay, this will act like a rectangle. So pH1 will be W into A1 into Y1 bar, upstream side. That is equal to 9810 into rectangle, means this is 6 meter and this is 4 meter. So 4 multiplied by 6 multiplied by y bar is 6 upon 2, that is 3. that is 3. That is 6 upon 2 is 5 bar. 3 meter. So pH1 is equal to 706.32 Newton. So pH1 I will write here. pH1 equal to 706.32 Newton. Then PV1 means this projected area in a horizontal plane. Okay, this is semicircle. This semicircle, that's so we want to find out pressure on this particular portion. Okay, so PV1 is equal to 9810 into pi into d square upon 4 area of the cylinder, but it is acting at semicircle, that is half, that is 2, into width of the cylinder is 4. Width of the cylinder is 4, yes, 4. That is equal to 9810 into 3.14 into 6 square is equal to divided by 8 equal to multiplied by 554.46. Yes, 554.46 Newton. Okay, so this is vertical one and this is in this direction. Okay, then pH2 will be 9810 into 3 into 2 into 2 into 1.5 that is 9810 into 6 into 1.5 equal to 88.290. Yes, so pH2 is equal to 88.290 in this direction, and PV2 is equal to 9810 quarter, it is quarter, so 9810 into pi into d square upon 4 whole divided by 4, that is pi d square upon 16 into width. So that is PV2 is equal to 277.37 Newton. Okay, so pH1 is equal to, or pH is equal to pH1 minus pH2, that is equal to pH1 is this figure and pH2 is this figure. So that is 706.32 minus 88.290, that is equal to 706.32 minus 88.290 equal to 618.03. 618.03 Newton, and PV is equal to PV1 plus PV2. Why it is so? Because both are acting in upward direction. Okay, in say another section, so it is PV1 is, yes, 554 point this, and I use another ink. Yes, so this is, and PV2 is this, and here PV2, it is this portion. We need to take this portion for PV2. So PV1 is 554.46 plus PV2 is 277.37. Let us work out this. 554.46 plus 554.46 plus 277.37 equal to 831.83. 831.83. So it is 831.83. Okay. So both the figures we got, pH and PV. Okay. Then we got PV and pH. Then PR is equal to, or FR is equal to under root pH square plus PV square. So that is under root of 61803 square plus 831.83 square equal to 692 under root 618.03 square plus 831.83 square equal to 1036.51. So this option is correct option. This option is correct option. Now tan inverse of PV upon pH, that is equal to PV upon pH is equal to 831.83 divided by 618.03 equal to this one, and inverse of tan inverse. So tan inverse equal to 53 degree 38 minute 85 second, that is approximately it is 53.39. This option is correct option. So it is tan inverse of 831.83 upon 618.03 is equal to theta is equal to 53.39 minutes. Okay, and lastly, what should be the weight? What should be the weight? That it should not be lifted away. So what is the net upward force? That is net upward force is, sorry, net upward force, not net upward force. So net upward force is PV. PV is equal to 831 net, 831.83. But this is in Newton, and we want answer in kg. We want answer in kg. So divided by 9.81. So 831.83 divided by 9.81 will be equal to 84.79. Where is that figure? 84.79, approximately 84.79 kg. 84.79, 31.83 upon 84.79. Yes, 84.79 is in this figure. A is right figure. Option A is right one. Option A is right one. So this is the solution. The problem number 1. I will take out second problem. Ask in the Babasaheb Ambedkar Marathwada University, Sambhajinagar. Figure is given here. A sector gate of 3.6 meter radius is mounted on the spillway of a dam as shown in the figure. So this is the figure. This is the figure. It is shown in here. And sector gate is 3.6 meter radius. So 3.6 meter radius gate. This gate is 3.6 radius, 3.6 meter radius. Its hinge at one end. So this is the hinge here at C. There is a hinge here. There is a hinge here. Okay. And one end of its is radial arm at the same horizontal plane with the water. So this is the water line. Okay. This is the water line here. What is the magnitude and the direction of the resultant pressure on the gate if the length of the gate is 3 meters? Very straightforward question asked in the examination. So we'll have a solution for this. So first of all, height of water surface above B. Let us find out the height of water surface. Height of water surface above B, above point B. So this point. Okay. So this is the vertical line straightway. So B into D. So BD. First of all, we'll have to find out BD. That is equal to H. Equal to H. H is what? 3.60 hypotenuse. 3.60 into sine 60 degree. So you will get the height. Okay. So yes. So that is H is equal to 1.8 into root 3. 3.60 into sine 60 degree. Okay. Then pH is equal to W into A into Y bar. WA into Y bar. 3. So 9810 into area of the gate. That is 3 meter is the width here. 3 meter is the width here. Yes. 3 meter is width here. So 3 into 1.8 into root 3 into 1.8 root 3 divided by 2 Y bar. This is Y bar. This is Y bar. So this value will be pH is equal to 1430 29.8 Newton. That is equal to 143.29 kilonewton. Kilonewton in this direction, horizontal direction. And PV equal to this sector gate. So 9810 multiplied by width of the gate is 3 meter. Now what we have to do? We have to take the weight of the body of this particular portion. Shaded portion. Okay, so it is sector gate, so 60 degree, so 1/6 part of the circle, 1/6 part of the circle into pi into r square area, that is 3.6 square, minus this triangle, that is BCD, that is minus triangle BCD, that is equal to or that is minus 1 by 2 into 3.6 cos 60 degree into 1.8 root 3, that is PV is equal to 117.032 Newton, that is equal to 117.202. So pH is equal to, and right here pH is equal to 143.29 kilonewton, and PV is equal to 117.202 kilonewton. Got it? So tan theta is equal to PV upon pH. That is equal to, tan theta is what? 0.819. Therefore theta is equal to 39.39 degree. 39.39 degree, that is equal to 39 degree 19 minutes and 55 seconds. This is the answer. These are the value. Okay, one thing we have forgotten here, we have not found out the resultant pressure. So resultant pressure is under root of pH square plus PV square, P resultant equal to. So that is equal to, let us work out here, pH square 143.29 square plus 117.202 square equal to, and we'll take under root of this equal to. So 185, that is equal to 185.11 kilonewton is the resultant pressure. So what value we got? Once again we'll check it here. So first of all, we find out pH value as this. So 143.29 pH value we got it here, and PV value we got it here 117. This kilonewton. Okay, then find out PR, that is resultant pressure, pH square plus PV square. So this square plus this square I'm taking under root. So we got 185.11 kilonewton. Okay, and PV upon pH we got 0.819 as tan theta value, and theta value we got it as 39 degree 19 minutes 55 seconds. So this is the second problem that we have solved here, that is based on the sector gate asked in the university examination.